Chapter 13, Annuities and Sinking Funds. In Learning Unit 2, we talk about the present value of an ordinary annuity. We calculate the present value of an ordinary annuity by table lookup and then manually to check our calculation, and compare the calculation of the present value of one lump sum versus the present value of an ordinary annuity. So let's assume that we want to know how much money we need to invest today to receive a stream of payments for a given number of years in the future. This is called the present value of an ordinary annuity. In figure 13.2 here, you can see that if you want to withdraw $1 at the end of each period, you would have to invest 93 cents today. If at the end of each period for 3 periods you want to withdraw the dollar, you'd have to put in $2.58 today in order at 8% interest. We're going from the future back to the present. So to calculate the present value of an ordinary annuity by table lookup, we have 3 steps to follow. Calculate the number of periods and rate per period like we've done in the past. Look up the periods and rate in the present value of an annuity table, table 13.2. This intersection gives the table factor for the present value of $1. Multiply the withdrawal for each period by the table factor. This gives you the present value of an ordinary annuity. So the annuity payment that you want to receive times the present value factor tells you the present value of the ordinary annuity payment. So if John Fitch wants to receive an $8,000 annuity in 3 years, interest on the annuity is 8% annually. John will make withdrawals at the end of each year. How much must he invest today to receive a stream of payments for 3 years? So step 1, how many periods do we have? 3 years times 1 annually is 3 periods. Our rate is 8% divided by once, because it's annually, is 8%. Our table factor, when we look at that intersection in table 13.2, is 2.5771. 2.5771 times the 8% that we want to withdraw each year for 3 years totals $20,616.80. So if John wants to withdraw $8,000 at the end of each period for 3 years, he needs to deposit $20,616.80 in the bank today. We can check this manually. If he puts in $20,616.80, he earns interest at the end of the first year of 8% on that balance. So his new balance is $22,266.14. He then withdraws his $8,000 annuity. His balance becomes $14,266.14. It stays that balance for the entire year, so he earns interest of $1141.29, making his new balance before his payment $15,407.43. His second payment is made of $8,000, so his balance becomes $7,407.43. That stays in the bank the entire year to earn $592.59 interest, making his balance become $8,002. He then withdraws his third payment of $8,000 to get an ending balance of basically zero. It's all due to rounding and some future calculations, but you can manually check it in this method. Lump sums versus annuities. John Sands made deposits of $200 to Floor Bank, which pays 8% interest compounded semi-annually. After 5 years, he made no more deposits. What will be the balance in his account 6 years after the last deposit? Step 1, calculate the future value of an annuity. We have 10 periods. He put in $200 semi-annually. So he put in the periods, it's semi-annually. So it's 5 years times 2 is 10 periods. His interest rate was 8% divided by 2, or 4%. So in our table 13.1 lookup, he has $200 that he's been putting in to get interest on. So 200 times our table lookup of 12.0061. His balance is $2,401.22 at the end of the 5 years. Then we need to calculate the final value as it grows. So what is the future value of this lump sum hanging out in his bank account? Well, it's hanging out there for 6 years, compounded semi-annually, so there's 12 periods. His interest rate is 8% divided by 2 is 4%. So we look up table 12.1, going back to chapter 12, to find the future value of the lump sum. Our table factor is 1.6010 times what we calculated as the amount that's in the bank, tells us that his future value of the lump sum is $3,844.35. So the first step, we said he had an annuity. He was putting away a series of payments. So he calculated the future value of that annuity. Then he stopped making payments, and we want to find the future value of the lump sum hanging out in the bank. Another example. Mel Rich decided to retire in 8 years to New Mexico. What amount should Mel invest today so that he'll be able to withdraw $40,000 at the end of each year for 25 years after he retires? Assume he can invest 5% interest compounded annually. Step 1, present value of an annuity. We want to determine the present value of his annuity that he wants to receive. So 25 years compounded annually. There's 25 periods. His interest rate is 5%. Annually is 5%. So looking up the present value of an annuity, we get a table factor of 14.0939. That times our annuity amount that we want of $40,000 is $563,756. Sorry. That is the amount that he would need to put away, but he's not withdrawing it now. He's not going to retire for another 8 years. So we need to find the present value of this lump sum of money. So there are 8 years until he retires. His interest rate is 5%. So table 12.3, to look up the present value of a lump sum, our lookup factor is 0.6768. So he needs $563,756 in 8 years in order to get a $40,000 annuity for 25 years. So the present value of the lump sum is $381,550.06. So he needs to invest $381,550.06 today to grow to $563,756 in 8 years. That amount of money will allow him to withdraw $40,000 at the end of each year for 25 years.